Hey guys, this is checkpoint 1.20. It read through it. It doesn't rely on the previous example 1.22, so I'm going to leave that information. Here we have James and Kathy, and they're racing on roller skates. Be careful, kids. They race along a long straight track, and whoever has gone the farthest after 5 seconds wins a prize. James can skate at a velocity, so I'm going to call this the James function. J of t equals, so I'm going to write down 5 plus 2t. And then Kathy, so k of t, jk. Anyway, 10 plus cosine of pi over 2t. Perfect, feet per second. So what we get to access from this problem is that if this is their velocity function, then the integral of velocity will be their position. So whoever has skated the farthest after 5 seconds, starting at 0, will ultimately win the prize. Well, the nice thing about this problem is that we could use definite integrals, go to Desmos and type it in, but this is fundamental theorem of calculus part 2. So we need to be able to solve or find the antiderivatives of our functions. And I also noticed that checkpoint 1.20 says the contest stops after 3 seconds. So I'm going to change my limits of integration from 5 to 3. Okay. You're welcome to look at the previous example just to see how they solved it. See, yes, we're in school. That'll happen again in a minute. What we're going to look at is the fundamental theorem of calculus part 2, and then after we get our results, compare them. So here we go. I'm going to go ahead and acknowledge, oh, by the way, I needed dt at the end of these. You're probably like screaming at the TV right now, or they're screaming at your screen. Thank you for not like breaking it. You know, that happens. Rage quit calculus, right? Here we go. I'm going to go ahead and just acknowledge, I'm going to take this whole antiderivative and this whole antiderivative of the integrand all in one step. I'm not going to necessarily worry about the sum formulas and how you can take out the scalar. All of that's useful information, but this is a pretty like vanilla, tame sort of a problem. So instead, I'm just going to jump right to it. The antiderivative of 5 would be 5t, and the antiderivative of 2t would be t squared. Told you. Evaluated from 0 to 3. Now I'm going to go ahead and calculate that down here where I have more space, but I might as well also find Kathy's antiderivative. So in this problem, it'd be the antiderivative of 10 with respect to t, and the antiderivative of cosine. Now, there's a problem here with this one, and we don't actually talk about it in this step. So I am going to use this as an opportunity to talk about what you're going to learn in a next example, and that is I'm going to do a little u substitution. I have cosine of pi over 2 t dt, and there's a problem, right? If I do a straight antiderivative analysis, I get to my point right here. I'm going to eventually have, you know, the result. But if I do the derivative and work my way backwards, I got to work my way backwards from whatever this antiderivative is. I have to get cosine of pi over 2 back. So something to consider in this problem is I'm actually going to take this right here and I'm going to call it u. We saw that in the previous examples with the limits of integration. Now I'm going to actually not focus on these definite constant limits of integration. I'm going to focus on the thing that's in parentheses. And then I'm going to do, let's write this with Leibniz notation. Let's find the du dt of that function. Well, it is nice. It's just pi over 2. But a step that I'm going to show right here is I want to actually end up solving for dt. Because this right here is something that we're going to do heavily more in detail, certainly more supported with future videos, that a u substitution occurs when there's layers of functions. It's kind of like the chain rule, or one of the chain rules for integrals. That's right, one of. We've got 3 heavy lift integral rules coming up. U sub is the nicest one. In order to get dt by itself, I got to multiply both sides by dt, and then I've also got to divide or multiply by the reciprocal 2 over pi. In other words, 2 over pi du equals dt. This is one of the ways to do this. I appreciate this method more than others because if I see the expression dt in the integral, I can swap it out with 2 over pi. So I'm going to rewrite. We have 10t. I forgot to put my limits of integration. Once again, thank you for not rage quitting at the computer. Where'd they go? They were there the whole time. It's just my brain. Plus the integral. I'm not going to put the 0 and the 3 down for a second. I want you to see why. But what I am going to do is I'm going to rewrite all of this with the dt, all of this integrand with the dt, now in terms of a u variable. We're swapping, we're substituting a u, single letter, into this problem. So we're going to have cosine of u, that's the easy swap, and then dt is actually 2 over pi du. Given that it's 2 over pi, we can put it outside. Okay? It's like the dog when the dog's passing gas. You get that thing out of there. That's a weird analogy. I'm sorry. Now, 0 to 3, right? So we're going to take this function u equals pi over 2 of t. These 0s and 3s, those are t values. They're the t equals 0. So technically that's a t equals 0. And a t equals 3. That's what they technically, like, definitely are. So if we're going to switch letters, we also got to switch letters up here, which means u of 0 equals pi over 2 times 0. Okay, no change. That's an easy one. But what about u of 3? Well, we got to put a 3 where the t is, which means we have 3 pi over 2. 3 pi over 2 goes for our new limits of integration. A u substitution, everything gets substituted with the u, which means that the argument inside cosine, the dt, becomes a du, and you have to be clever about it. Also, the limits of integration, they were t values, and with the u substitution, we got to turn them into u values. Now I'm ready to fundamental theorem of calculus this whole thing out. All right, j, which I'm curious about what I should use right here. You know, I might just not. I might just jump into it and be like a colon. This is j's distance after 3. I could do that. J of 3 equals. That's a little bit like I'm fudging, but I'm sorry. 5 times 3 plus 3 squared minus, and this is going to be an easy calculation, but I'll show it, 5 times 0 plus 0 squared, right? That's all 0, so minus 0, so gone. 5 times 3 plus 9 squared, 24. That guy's got some speed. He gets 24 feet in 3 seconds. How about Kathy? Let's see what Kathy can do in 3 seconds. So she's got 10t3, so 10 times 3 minus 10 times 0. That's the fact that the limits of integration being 0 and 3. That's going to cancel out to 0. Over here we have plus 2 over pi times cosine of 3 pi over 2. Ooh. There's something special about that one. That's kind of weird. Minus, put that all in parentheses, because the 2 over pi is on the outside, so 2 over pi has to be outside the parentheses. Cosine of 0. Which cosine of 0 is... This is 0, right? You look at the unit circle, and 3 pi over 2 is on the lower, like it's on the negative y-axis, and then cosine of 0 is on the positive x-axis, so this would be 1. In other words, 30 plus 2 over pi, what's with that little mark right there? Get rid of that mark. Thank you, pencil. Minus 1. No, times negative 1. That's 0 minus 1, so that'd be negative 1. And then, yeah, let's go evaluate this. This is the nice exact answer, by the way. An exact answer would be 30 minus 2 over pi. So which is more? The distance James travels in 3 seconds on his roller skates, or the distance Kathy travels in 3 seconds on her roller skates? And it seems like it's probably going to be Kathy's distance, but let's get some decimals. You don't go to Safeway and walk through the check stand and have the person at Safeway, the cashier, say, thank you, that'll be 30 minus 2 over pi dollars. If they did, blow your mind. And you'd say, hold on, professor. And you'd get out your phone and you'd go to like Desmos or something and you'd actually evaluate it. So we're going to do that too. 30 minus, it's got to be like 2 over 3. So it's approximately 30. I'm going to do some math first. So it's approximately 30 minus 0.6. I'm going to say 29.4 as a good estimate. Boom, 29.363. Thanks for watching this video.